about 60 thousandths in diameter for yeah, about 50 or 60. And I hardly ever use these big ones, except I use them as punches. These would be used on like a baritone saxophone. These blued steel springs generally don't come with the flat spot on them. So you're going to want to have some sort of a steel bench block or something you can hammer on, maybe an anvil, or vices usually have an anvil on them. And you're just going to hammer the flat spot that you need on there. These springs tend to be made in large bundles. And the way you harden and temper a spring is to heat it red hot and toss it in a liquid cooling, and it'll sizzle and they'll harden, and then you heat them again to a lower temperature. To harden them, you heat them to about 1300 degrees and plunge them quickly in a liquid. And they tend to do that in big batches, and the ones on the outside cool fastest and get hard and too hard and brittle, and they break easily. The ones inside don't get hard enough, and so it's hard to find good quality, consistent quality springs. Sometimes when you hammer them, they just split on the end. It can be helpful to heat them slightly with a torch. I have my jeweler's acetylene torch here. And you just want a small flame, and you don't want to heat it very much. This is a large spring, but that would be more than enough on a smaller spring. And that will soften it just enough that you don't split the end of that when you hammer it. And don't overdo it. It's not going to take as much as I just did on a small oboe spring. And that's replacing needle springs. The other type of spring we have on oboes are called flat springs. They might also be known as leaf springs. You generally have one on the bridge key here, a rather heavy one, because it has to work against other springs in the left-hand section. A rather light one on the bottom of the first octave key. These are some Junker Parts oboes I'm using just to show you. That one's actually broken. You have a rather heavy one here that works against the E-flat key, and that has to be bent in such a way. That's kind of a tricky spring to get right. You might break 2 or 3 if you have to replace that before you get it in there right. And then you have some lighter ones on the E-flat and the C-sharp key. Here's one here. And if you're replacing those, well, they come in basically 3 different styles. You can get blue needle springs like, or flat springs like this, or a stainless steel. They also come in bronze, which tends to feel a little bit lighter. I would measure them with my dial caliper and try to replace it with something as close to that as possible, unless you're deliberately looking to change the thickness of it. This one reads at 17 thousandths. And they're sold that way, but by the thickness of them and the length. You're likely to have to trim it a little bit size-wise to fit. I'm going to use these cut-off pliers here to trim a little bit off the end. It often sits on wood, or maybe there's a little piece of metal spring glued to the wood so it has something to slide against. You want a nice curve to the spring. And then the end, you want it to be curved up so it's not digging into the wood. So I'd put a little curve on the very end of the spring. And you don't want a sharp edge, so I'm going to use my sharpening stone here. You could use a little grinding wheel or something, just to kind of round out nicely the end of the spring there, so that it's smooth and can rub a little bit against the wood or piece of metal maybe that it has to rub against so it doesn't stick. The screws to hold those usually go into the key. This one screw on this E-flat spring here goes directly into the wood. The screws are generally one of two sizes, and I've got this pair of tweezer screwdrivers I got from Fariz. These run about $15, and they're real handy to have. They help you hold these small, really tiny screws, and that's how you can easily install those. The screws tend to be one of two sizes. This one is probably an OOD 80. That means the diameter of this screw is 60 thousandths of an inch, and it's 80 threads or turns per inch. The other common size is 172, especially on some of the European instruments, and that would be 73 thousandths diameter and 72 threads per inch. You can buy those screws from the suppliers, or if you have a few junk horns around, you can rob parts off of that. And they're bound to have some of these screws that you can use. And that's replacing flat springs.